Okay, I'm going to show you actually another video that's powered to 10 billion at the moment, but I just want to make a point here. Can anybody pick the projector? It seems like one of those things where you have to pick it. Okay, so this is a sort of graphical depiction of the entire life of the universe. We're out here right now. We're approximately on that dot right there. But anyway, so time is running from left to right here, and the vertical radius of this cone is like the radius of the universe. Now, what we've got here is the entire universe at a given time is depicted as a flat disk instead of like a three-dimensional universe, because you can't make a plot like that. So we're just treating the universe as a flat disk with a certain radius to indicate its size. And in the initial Big Bang, there actually was essentially zero radius. So everything grew out of a single point that was probably smaller than a pinhead. You can imagine. Nobody can imagine it, because the densities of matter involved, I mean, and conceivable. We don't even really have a physical theory that can describe the behavior of matter like that. We can go within a few certain fraction of a second of the Big Bang and understand all that physically, but we can't get any closer than that because it becomes so extreme. We don't have a theory to cover that. But what we find is that early on, matter and radiation, well, there actually isn't any matter. It's just kind of a quantum soup of stuff that sort of pops out of nowhere as far as we can tell. Although there's some theories about what might have actually caused the Big Bang. But anyway, eventually there's enough expansion that the radiation is able to move freely amongst the matter, and you actually have light moving around for the first time. And then you have galaxies forming and stars and things like that. And so we get to the point we're at now, which is a pretty large universe. We think it's pretty large, about 13 billion light years across. So if we're here on this speck, and we're looking at a star or a galaxy over here, let's say this is 10 billion years in distance right there. Okay, 10 billion light years in distance. So if we're there and we're looking at radiation that we're receiving from that galaxy, it's 10 billion light years away. So what that means is it took light 10 billion years to reach us from that point. So when we look at that galaxy, we're actually seeing it as it was 10 billion years ago. It's the whole time machine aspect of astronomy again, right? And so the farther out you can look, which we're going to be able to do with the Webb telescope, the farther back in time you look until you actually can start to see something pretty close to the Big Bang. Yes? How do you know how big the universe is? Well, it's essentially based on the largest scale of structure that we can see. I mean, there's actually no real barrier or anything like that. So ultimately, the actual radius is determined theoretically, I have to say, for models of how the explosion took place. Because there's not really any definitive way to look out and say, you can't really look out and say, oh, that's it, the universe right there. Because actually the problem is, the farther out you look, the farther back you're looking in time. You're not just looking far away. So the farther out you look, you're actually looking farther closer to the infant universe itself. So there's almost kind of a distortion because of that. So anyway, the answer is that we see larger and larger types of clusters of structure out to about 13 billion light years or so. And we just can't see anything beyond that. We don't know. It's hard to know. But when we get to that distance, we see things that look incredibly young. And again, if you could look far enough away that you saw things that were 0 at age somehow, well, that's the end of the process. Keep going farther than that. Looking back at the Big Bang itself, essentially. Anyway, so long answer. Yeah, we can do about 13 billion years. Okay, so this powers of 10 video, which I'm going to show now, only about 10 minutes or so. And it's kind of a cute little thing that starts with us and actually expands out to show you the scale of the universe, and then zooms in to show you the microscopic scale all the way into like the nucleus of an atom or something like that. Okay, so we'll show you that, and then we'll start getting into the real meat of the material from chapter 1. Now, if anybody actually still needs to add the course, I do have some course that have forms with me, so I don't know if that's an issue for anybody. I have some of the forms with me. So, okay, let me go ahead and see if I can get this to work.